Okay, so guys, we worked already on solving systems of equations. So now we're going to figure out what does it mean to solve a system of linear inequalities, okay? The solution to a system of inequalities are where the shading of each inequality overlaps. So if you do not have two different color map colors right now, I would pause the video and try to find two different color map colors or maybe pins. Two different colors is going to be very helpful on this. Okay, so we're going to graph very similar using our y-intercept and our slope, but with inequalities, we have to decide whether we use a solid or a dashed line, and we're going to have to decide whether we should shade above or below. So on this first one, I know my y-intercept is a 5, so I'm going to go put a point at 5 on my graph. Oops. My slope is a -2, so from my y-intercept, I'm going to go down 2 over 1. Down 2, right 1. Repeat that. Okay, so now I need to decide, should I make a solid or a dotted line that goes through these points? So if I look at my symbol here, I notice there is no solid line underneath, so I know I want to use a dotted line. So I'm going to use a dotted line that goes through these. So you still want to use a straight edge. So still use a straight edge, but make sure you have a dashed line. The importance of a dashed line is telling me that if I have a point that falls on top of the line, I think of it as like a broken bridge. If you're like walking on this, you're going to fall through. So if it's on top of the line, it does not count. It's broken. On top of a broken line does not count. Okay, so now we're going to talk about where we need to shade. Well, this says greater than, so greater than means we have to shade above. So all of this is below the line underneath it, and all of this is above. So I'm going to shade lightly, okay? So shade lightly everything above that broken dotted line. Okay, so now that we're on our next equation, I'm going to use a different color. Use green. So on this next one, I know my y-intercept is a -3, so I'm going to go down 3 and put a point. My slope is a 1, so it's 1 over 1. So up 1 over 1, up 1 over 1. Once we have our points, we have to decide whether we use a dotted line or a solid line. Well, if I look at my symbol, I see the solid line underneath, so I need to make sure I draw a solid line that goes through those points. All right, next we have to talk about shading. Excuse me. Okay, so this symbol says less than, so I know I'm going to have to shade below that green line. So all of this is below, so I'm going to shade lightly below. Okay, so now that we have both of these inequalities graphed, let's talk about where the solutions are located. So your solution is going to be where your pink shading, or in my case, I use pink and green, where my pink shading and my green shading overlapped. So I can see that the shadings overlapped in this little triangle section here. So what I'm going to do is I'm either going to maybe use a pencil if you're at home, or use one of your other colors, and I'm going to darken this area because I want to make it obvious where my solutions are located. Okay, so this section right here, this is the section where anything in here could be a possible solution. There's too many to count. That's why we're having the shading. Like, you couldn't even name all the possible solutions. So, but we do need to talk about the solid versus the dotted line. So if I land on this solid line right here, it counts as part of the solutions. But if I land on this piece of the triangle, you see how it's a broken line, dotted line? If it lands right on top of it, it would not count as part of the solutions. Anything inside of here would count. Any of these points, pick any of those are possible solutions. One other place I want to talk about is the intersection right here. So this point where the two lines intersect, the point of the triangle, would that be included as a solution? Well, remember, a solution has to make both equations true. Well, it's on top of a solid line, so that's good, but it's also on top of the dotted line. So since it's on the broken line at all, this point right here where the two lines intersect would not be considered a solution because it doesn't work on both of them. It would fall right through that pink one. So any of this piece over here, those are solutions. And anything inside this dark blue, those are solutions. None of this. And none of this outside stuff. None of this pink, none of this green, none of this. Okay, I'm going to start with pink. My y-intercept of this first guy is a -3, so I'm going to go down 3 and put a point. My slope is a -2/3, which is going to tell me from here I need to go down 2, right 3. Down 2, right 3. Down 2, right 3. Okay, so let's talk about whether we want a solid or a dotted line. So I look at my symbol, I see the solid line underneath, so I know I'm going to use a solid line. So use your straight edge and draw a solid line that goes through those points. Now we need to talk about shading. This is a less than symbol. Less than means to shade below. So lightly I'm going to shade the area underneath the line, below the line. Alright, so now that we're finished with that one, I'm going to pick my different color. I'm going to go back to green. And now I'm going to graph this guy. So I know my y-intercept is 8, so I'm going to go up 8 and put a point. My slope is 3, which is 3/1, which means from here I need to go up 3. Uh-oh, I don't have room to go forward. So what I'm going to have to do is put it in reverse, so do everything backwards. So instead of going up 3, right 1, I'm going to do the opposite and go down 3, back 1. And I'm doing this because we didn't have room to go forward, so we're going to put it in reverse, do everything backwards. So down 3, back 1. Down 3, back 1. Okay, once you have your points drawn, we have to decide whether I should use a solid or a dotted. So I look at my symbol. I see the solid line underneath, so I'm going to use a solid line. So use your straight edge and draw a solid line that goes through those points. And let's talk about where we should shade. Well, this is a greater than symbol, so I know I need to shade above. So on the top side of it. So above would be on this side of it, above that line. So I'm going to lightly shade everything above that line. So let's talk about solutions again. We know the solutions is where the two shadings are going to overlap. Well, I can see that they're overlapping in this little triangle section right here. So either take your pencil or take a color and darken it in to where it's obvious where your solutions are located. Okay, so that's the section where any solutions are located. So let's talk about these pieces, the edge pieces. So along this edge of the boundary, I know it's a solid line, so anything on top of it is included in these solutions. Let's talk about this edge over here. This is also a solid line, so I know it is also included in these solutions. And let's talk about this point of intersection right here. Remember, it has to work for both lines. Well, the green line is solid, so it works for the green one. The pink line is solid, so it works for both of them. So this point is a solution. So this point, any of this point, any of this way, and anything in this dark shaded region are solutions. All right, I'm going to go back with pink. And I need to graph this guy, but unfortunately y is not by itself, so that's what I'm going to do. I'm going to take away 5x's from both sides. My negative 6y is going to drop down. My symbol drops down, and I'm going to have 42 minus 5x. Next, I need to get rid of that negative 6, so I'm going to divide by negative 6 on both sides. My y drops down. Okay, so let's see if we can remember. We just divided both sides by a negative, so there's a special rule that we have to do. When we divide both sides by a negative, we have to remember to flip-flop our sign. Next, 42 divided by negative 6 is going to give me a negative 7. And then this negative 5 divided by negative 6 is going to give me a positive 5 over 6, and the x drops down. Now I can graph it. My y-intercept is negative 7, so I'm going to go down 7 and put a point. My slope is a positive 5 over 6. So from here, I need to go up 5, right 6. So before I draw my line, I need to look at my symbol to decide whether I should use a solid or a dotted line. So if I look at the symbol, I see there is no solid line underneath, so I want to use a dotted. So line it up with your straight edge. So line it up with your straight edge, but remember to use a dashed line. Okay, now let's talk about shading. Should I shade above or below? So I look at my symbol right here. This says less than, so I need to shade below. So I'm going to lightly shade underneath, below my line. Choose a different color. And now let's work on the next one. I'm going to solve for y by taking away 3x's from both sides. My 2y falls down, my symbol drops, and I'm going to have 14 minus 3x. My next step, to get rid of that 2, I'm going to divide both sides by 2. So my y drops. There's no reason to flip my sign. 14 divided by 2 is 7. Negative 3 divided by 2 is a negative 3 over 2, and my x drops down. So now that y is by itself, I can graph. My y-intercept is 7. My slope is a negative 3 over 2, so from here I need to go down 3, right 2. Do that again. Down 3, right 2. Once your points are drawn, we need to talk about whether we should use a solid or a dotted line. So I look at my symbol. I see that there is a solid line underneath, so I'm going to draw a solid line. So use your straight edge. And draw a solid line that goes through those points. Okay, now I need to decide whether I should shade above or below. So if I look at that symbol, it's a less than symbol. Less than would be below. So underneath the line, below, under the line. So here's my green line. I need to shade everything below it, under it. So remember, shade lightly. Okay, so now that I have them graphed and I can see where my shadings overlap, I'm going to take either a pencil, I'm going to use my blue color, and darken it in so it's obvious where my solutions are located. So my solutions are any point inside that darker area. So let's talk about the boundaries. I know anything on this side counts because it's on top of a solid line. Anything along this boundary does not count because that's a broken dotted line, so it would fall through. Anything in here would count. But let's talk about the intersection where they cross each other, this point right here. So because it's on top of a solid and a dotted line, it's not going to work because it doesn't work for the broken line. So that intersection is not included as a solution. All right, again, let's solve for y by taking away 7x's from both sides. My 3y falls down, my sign drops, and I'm going to have a negative 24 minus 7x. Next, I'm going to get rid of that 3 by dividing by 3 on both sides. Y falls down. There is no reason to flip our sign. Negative 24 divided by 3 is a negative 8. Negative 7 divided by 3 is a negative 7 over 3, and the x falls down. So my y-intercept is negative 8, so on the y-axis I'm going to go down 8 and put a point. My slope is a negative 7 over 3, so that means I would have to go down 7, right 3, but I don't have room to do that, which means I'm going to have to work in reverse, backwards. So instead of going down 7, right 3, I'm going to go up 7, back 3. Do it again. Up 7, back 3. So now that I have my points, let's talk about what type of line I need to be using. So I look at my symbol, I see a solid line underneath, so I'm going to use a solid line to draw my line. So take your straight edge, line it up, and draw a solid line that goes clear across your graph. This is not working very well. That's better. And let's talk about shading. Well, I see that this is a less than symbol, so that means I need to shade below, underneath. So I need to shade the area underneath or below my line. So remember to shade lightly. So I'm picking green to move on to my next one. So I've got to solve for y, so I'm taking away an x from both sides. 3y is less than or equal to negative 6 minus x. Next step is to divide both sides by 3. So y, there is no reason to flip my sign. Negative 6 divided by 3 is a negative 2. Remember, this is a negative 1, so a negative 1 divided by 3 is a negative 1/3, and my x drops down. So now I can graph this one. My y-intercept is a negative 2. My slope is a negative 1/3, which tells me from here I need to go down 1, right 3. Down 1, right 3, down 1, right 3. All right, once you have enough points, you can talk about what line we need to draw. While I look at my symbol, I see a solid line underneath. So let's use a solid line. Use a straight edge, line it up, and draw your solid line throughout. And now the shading. This symbol says less than, which means I need to shade below that line, underneath that line. So lightly shade underneath that line. So you should be able to see where the shadings overlap. So use either your pencil to darken it in. I'm going to use this blue color. Here. So I know any point inside of this darker area where the shading overlapped are solutions. Let's talk about the boundaries. So this line and this line. Solid line, so this one, anything on this boundary counts. Solid line, anything along this boundary counts. Let's talk about where they overlap. Since both lines are solid, it counts on both of them, so this intersection point would also be included. But remember, none of this is a solution, none of this, and none of this. Okay, solving for y. Taking away x from both sides. So my negative y is going to drop, my sign drops, and I have 3 minus x. Okay, y is not by itself. To get rid of that negative, I'm going to multiply the entire thing by another negative, which is going to make everything opposite. The opposite of a negative y is a positive y. The opposite of this greater than symbol is a less than symbol. The opposite of a positive 3 is a negative 3, and the opposite of a minus x is a plus x. So now I can graph it. My y-intercept is negative 3. My slope is the number in front of x. Well, that's a 1x, so my slope is 1, so 1 over 1, which means from here I need to go up 1 over 1. Up 1 over 1. So once you have your points, you need to talk about what type of line we should draw. Well, notice there is no solid line underneath, so I know I need to use a dotted line. So take your straight edge, line it up, but make sure that you are using a dotted line. And now let's talk about shading. It's a less than symbol, so I need to shade below that dotted line. Remember to shade lightly. On my next one, notice y is missing, so it's a weird one. X, so I know it's going to be a vux. That's going to help me because I know that's going to be a vertical line. So first, let's go to where, go put a dot on the x-axis at 6. Let's talk about what type of vertical line. Do I want to use a solid or dotted? Well, I have a solid line underneath it. So I'm going to draw a solid vertical line through that point. Okay, that's a greater than symbol, which typically means above. Well, you can't really shade above this line. You can shade behind it or in front of it, to the left or to the right. Well, what makes sense for greater? To the left of it, behind it, or to the right of it, in front of it? To the right. So I'm going to shade everything to the right. Once you see where they overlap, you can darken it in. So anything in here includes my solutions. Let's talk about the boundaries. Anything along this boundary counts because it's solid. Anything along this boundary is broken. It's dotted. It does not count. The intersection, because it's on top of one solid but also one broken one, it does not count. Anytime it's on top of a broken at all, it will not count. So any of this side over here, and then anything inside the shaded region, the dark shaded where they overlap. Nothing here, nothing here, nothing here. And I'm solving for y again by taking away x from both sides. Negative 3y falls down, my symbol drops, and I'm going to have 12 minus x. Divide both sides by negative 3. We just divided both sides by negative, so we have to remember to flip our sign. 12 divided by negative 3 is a negative 4. Remember, this is a negative 1. Negative 1 divided by negative 3 is a positive 1/3, and the x falls down. So my y-intercept is negative 4. My slope is 1/3, so up 1, right 3. Up 1, right 3. Up 1, right 3. I see a solid line under my symbol, so I'm going to use a solid line. So use that straight edge to make your solid line. And it says less than, so I know I need to shade below. On the next one, I'm going to take away 2 x's from both sides. My negative y falls down, the symbol drops, and I'm going to have a negative 6 minus 2x. To get rid of that negative, I multiply the entire thing by another negative because it's going to make everything opposite. So that's going to give me a positive y. I need to take the opposite of my sign. It's going to give me a positive 6 and a plus 2x. So my y-intercept is 6. My slope is 2, which is the same as 2 over 1, which is telling me from there I need to go up 2 over 1, up 2 over 1. Once we have our points, we need to talk about what type of line to use. Well, I see the solid line under my symbol, so I'm going to use a solid line. And I see that it is also a less than sign, so I'm going to shade below that line, underneath it. Once we do that, we can see where they overlap, so I'm going to darken that region. So I can clearly see where my solutions are located. So anything in here is a possible solution. Let's talk about boundaries. Anything along this side would count because it's solid. Anything along this side would count because it is also solid. The point where they intersect, since they are both solid, this point would also count as well. None of this, none of this, none of this. All right, so I'm going to solve for y. By subtracting 3x's from both sides. 4y falls down, my symbol drops, and I'm going to have 28 minus 3x. Next, I have to divide both sides by 4. No reason to flip our sign. 28 divided by 4 is 7. Negative 3 divided by 4 is a negative 3 over 4. And my x will drop. So my y-intercept is 7. Since my slope is a negative 3 over 4, I know from here I need to go down 3, right 4. I'm going to do it again, down 3, right 4. And now I need to talk about what type of line to draw. There is no solid line underneath, so I know I need to use a dotted line. So line it up with your straight edge. But remember to use a dotted line. Mine's off a little bit, my bad, guys. Let's see if I can fix that. It's hard to make dotted lines on this. Alright, well, that's pretty good. Alright, let's talk about shading. That is a less than symbol, so I'm going to shade below that line. Okay, so let's solve for y on this next one. And I'm going to do that by taking away an x from both sides. My negative 2y falls down. And that's going to give me 0 minus x. You don't have to put that 0. You can just leave it as a negative x if you like. But I'm going to leave it for now just because I think it helps some people visualize. Alright, so let's get rid of that negative 2. So I'm going to divide both sides by negative 2. My y falls down. We just divided both sides by a negative, so I have to remember to flip my sign. 0 divided by a negative 2 is 0. Remember, that's a negative 1. A negative 1 divided by a negative 2 is a positive 1/2, and the x falls down. So really, guys, you don't need to have that 0, but that 0 is showing me my y-intercept. So on the y-axis, I'm going to go put a dot at 0. And we said our slope is a positive 1/2. So from there, from my y-intercept, I'm going to go up 1, right 2. And do it again, up 1, right 2. Up 1, right 2, up 1, right 2, up 1, right 2. So before we draw our line, let's talk about what type of line we need. I see a solid line underneath, so I'm going to use a solid line. I also see a greater than symbol, which means I'm going to have to shade above. So let's go use our straight edge to draw a solid line. And then we said to shade above. Once that is done, you should be able to see where your shading overlaps. So I'm going to go darken it in so it's obvious which section is my solutions. So I know my solutions fall in this area. Let's just talk about the boundaries of this area. Anything right here on this line counts because it's solid. Anything over here on the dotted will not because it's broken. Let's talk about the intersection. One is solid, but the other one is broken, so it doesn't count on both of them. So this intersection point would not be included. So not the intersection point, none of this, all of this side, and anything in this dark shaded area. Okay, so the next part is asking which of the following points are solutions to the system. So I'm going to plot each of those points. Let's see if I can get this right. It's a little too big yet. It's so glitchy. All right, I'm going to try to use a completely different color. Let's see. See if brown will show up. Okay, my first point is at 1, 3. So let's go put a point at 1, 3. I'm going to zoom back in. 1, 3. So from the origin, I'm going to go right 1, up 3. My brown point, that's 1, 3. I went right 1, up 3. Is that point a solution? Well, notice it's in my dark shaded area where the two overlap, so yes, it is. So that one is a solution. So now let's try 3, -4. So from the origin, I'm going to go forward 3. -4 tells me to go down 4. Well, 3, -4 is in the pink shaded area, but is it a solution? No, because my solutions are over here where they both intersect. So 3, -4 is not a solution. My next point is 0, -5. So 0, that means you're at the origin. -5 means to go down 5. So that point is 0, -5. Notice it is not where they overlap, so this one is also not a solution. Final point, -2, 0. Let's check that one out. -2 tells us to go back to 0. Okay, that point is inside where they overlap, so that point is also a solution. This isn't on there, but I'm going to add one. Question, what about this point right here? It's on the boundary, but would this point be a solution? Well, the answer is no, because it's on top of the broken line, does not count. What about this point? This point. It's on the boundary, it's on top of a solid line, so this point does count. And last one, this intersection. Would this one count? The intersection of our two lines, the point of where the solutions are at. The answer is no, because although it's on a solid line, it's also on the broken line. It has to work for both. So this one would not be a solution either. All right, that's it. Bye, y'all.